This is 111 West 57th Street, 1,428 feet tall, barely wider than a tennis court, the thinnest skyscraper ever built, $2 billion to construct. Most of it sits dark every night. What actually holds a 1,400-foot needle upright when the wind hits it? Why does the building move, and why do the people inside feel it? How do you engineer 3 separate systems just to manage air and still end up with floors open to the sky? And if the engineering worked, why does the developer himself say this project failed? When the site at 111 West 57th Street was first assembled in 2013, the address alone told the story. 1 block from Central Park, Billionaires Row. The same strip where 157 had already proven that ultra-wealthy buyers would pay prices that defied logic for a Manhattan address above the park. The developers projected a total sellout of $1.45 billion across 60 units. Apollo's chief operating officer estimated apartments would trade at $7,000 to $10,000 per square foot, numbers that at the time seemed conservative given the location. But the building itself was something no one had attempted before. A slenderness ratio of 124 for every 24 feet of height, the structure is 1 foot wide. Stack a standard pencil end to end 1,400 times and you have the proportions. The engineering team at Shop Architects knew they were walking into problems that had no established playbook. The foundation alone would require solutions that had never been tested at this scale. Steinway Hall, the landmarked 1925 piano showroom at the base, had stood on that corner for nearly a century. It had housed Steinway & Sons hosted recitals and survived the full arc of Manhattan's 20th century. Now it would become the base of the most structurally extreme residential tower ever attempted. The developers called it the most extraordinary residential address in the world. That was the plan. Here's what actually happened. The building was trying to pull itself out of the ground. Most people assume the danger with a thin skyscraper is lateral wind pushes building tips. That is the obvious fear. It is also not the hard problem. When wind strikes a structure this tall and this narrow, the force doesn't just push sideways. It transfers down through the frame and creates what engineers call uplift, a vertical pulling force at the foundation. Think of it like a stake being yanked straight up out of frozen ground. On a wide building, the sheer mass spread across a large footprint keeps the physics manageable. On Steinway Tower, the footprint is the size of a modest house. There is nowhere near enough weight at the base to resist what the wind generates at the top. The solution was 200 steel anchors drilled into Manhattan bedrock, each one running nearly 100 feet straight down. Not pilings. Anchors. The difference matters. Pilings carry weight. Downward anchors resist upward force. Each rod connects the base of the structure to the rock of the earth, the way a turnbuckle cable ties a utility pole to the ground in a storm. Except each cable here is a steel shaft the length of a 10-story building, and there are 200 of them. The concrete mix required for walls thin enough to maximize sellable floor area ran to £14,000 per square inch, nearly 3 times standard building spec. Every square inch of wall had to carry more load because there were so few square inches to work with, and that was before they started building up. Then the wind found 3 more ways to make the building unlivable. Once the foundation was solved, the engineering team ran into the next problem, and then the next one after that. Wind around a structure this thin doesn't flow cleanly past both sides. It wraps around the edges separate and creates spinning pockets of air called vortices that alternate left to right in a steady rhythm. Left release, left, right. On a short building, nobody notices. On a 1,400-foot needle, that alternating rhythm builds into a sway the occupants can feel. And in the worst case, when the frequency of the vortex shedding matches the natural frequency of the structure, it amplifies. The building begins shaking harder with every cycle. It's the same principle that tells soldiers not to march in step across a bridge. Synchronized rhythm can tear a structure apart. The engineering team deployed 3 countermeasures simultaneously. The exterior edges of the building are stepped and feathered, not flat, to disrupt airflow before it can organize into a clean vortex pattern. The entire facade is wrapped in hand-laid terracotta tiles, 22 distinct panel variations whose rough surface creates micro-turbulence the instant wind touches it. Chaotic air cannot build the steady alternating rhythm that causes dangerous sway. And at the 51st, 71st and 86th floors, the building has gaps blow-through floors open to the sky where wind passes straight through rather than building pressure against a solid wall. 3 floors of the most expensive real estate in Manhattan sacrificed entirely to airflow management. At the crown, an 800-ton tuned mass damper, a steel block the size of a small house suspended on hydraulics, shifts opposite to the building's sway. When the tower moves left, the damper moves right. The motion cancels before residents feel it. In October 2020, Hurricane Zeta tested all of it. The building was still under construction. The crane at the top got caught in the storm. The crane ball, a massive steel counterweight, broke free and began swinging in slow, enormous arcs hundreds of feet above 6th Avenue. Then it hit the building. Structural damage, delays, more costs on a project already bleeding money. 2 years later, after the building opened, a chunk of ice detached from the upper floors and struck a motorist on the street below. The person survived. The story ran everywhere. The miracle of engineering on Billionaires Row was now being reported as a falling debris hazard. Then it gets worse. What $50 million a night actually feels like. Say you ignored all of it. Say you had the money, loved the concept, signed the paperwork, and moved in. Here is what the building actually delivers. The views are real. On a clear day, you see the full length of Central Park from above the Hudson to the west, the East River to the east, the city grid spreading to the horizon in every direction. No wider building on that block can replicate that perspective. The finishes are world-class. The ceiling heights, the materials, the fixtures, everything selected to justify the number on the price tag. Then the wind picks up. The building moves. Not violently, the engineering did its job. A long, slow sway like standing on the deck of a large ship, in a gentle swell. Residents have described it. Some find it tolerable. Some find it deeply unsettling in a way that never fully goes away, no matter how many months they live there. At night, the building creaks. Steel and concrete flexing under shifting wind loads make noise, low structural groans that travel through the walls and floors. This is the building doing exactly what it was designed to do. But lying in bed at 2 a.m., listening to the walls groan like the hull of a ship, is not an experience most people pay $50 million to have. Getting water to the upper floors requires pump systems powerful enough to overcome the pressure differential at that altitude. Those systems run continuously. They make noise. The elevators travel so far and so fast that pressure changes in the shaft create their own physical sensations, a brief compression, an ear pop, a moment of disorientation at the end of every ride. These are not defects. They are physics. They are also permanent features of the address. And here's the part nobody wants to answer. $2 billion, no approved budget, 1 foreclosure. By mid-2017, the tower had reached 20 stories, less than a quarter of its final height, and was already $50 million over projection. Investor Ambase filed suit in Manhattan Supreme Court. Their attorney's explanation was direct. The developers had omitted construction cranes from the budget. Cranes, the most visible equipment on any high-rise job site in New York, where crane operations on a tower this size run into the millions of dollars. When JDS and PMG filed their countersuit, their defense was plain. Since there had never been an officially approved budget, there was no baseline against which overruns could be measured. A $2 billion construction project proceeding without a formally approved budget. Apollo's $325 million mezzanine loan went into default. The foreclosure wiped out Ambase's $66 million equity stake entirely, while the primary developers retained ownership and construction continued. The building was completed in 2022, 8 years after groundbreaking. Total cost had exceeded $2 billion. In August 2023, Apollo wrote off a portion of its $325 million loan, a formal acknowledgement that the money was not coming back. By April 2025, 10 units remained unsold. That gap didn't close itself. It came from the people who believed the original numbers, and all of it traces back to one decision. The crane budget was zero on a $2 billion tower. Nobody put it in writing, and the zoning that made all of this possible is still on the books. This wasn't a structural failure. The building stands, the damper works, the anchors hold. It was a system that allowed 60 ultra-luxury units to occupy a footprint that could have housed 442 standard apartments in one of the most housing-constrained cities in the country. The engineering was extraordinary. The accountability was not. Nobody who approved the budget that didn't include cranes lost their license. Nobody who signed off on a $2 billion project without a formally approved baseline faced consequences. The investors lost everything. The lender wrote off hundreds of millions. The people who bought in at $50 million are lying awake listening to their walls flex in the wind. Would you have signed that contract? Or would you have walked away before the first anchor hit bedrock? 157 one block east on the same street went through its own foreclosure auction while this tower was still under construction. The model on Billionaires Row isn't new. You just don't know which building is next. The project you just watched took years to fail publicly. The next one on this channel took longer and cost more. Subscribe, because by the time it makes the news, it's already too late. Comments are open. Name your city.